Hi and welcome to Maths class. Today we are looking at applications of circular functions, which really is situations in real life where circular functions might make themselves useful. I'm going to go through one worked example only, but as I do, I'm going to talk a little bit about the process and the things that I'm going to do my calculations. So the example's quite long, so it doesn't quite fit all the way on my screen, but I'll read through it with you. So the depth of the water in a channel can be approximately modelled by this equation. And we've got d of t equals 2 sine pi over 6t plus 6, where t is the number of hours after midnight and d is the depth of the channel in metres. And our first task is sketch the graph of y equals d of t for the domain from 0 to 24. Then B, find the depth of the channel and the time of day at high tide. C, calculate the depth of the channel at 4 a.m. Is the tide coming in or going out at this time? And finally, D, a ship needs a minimum depth of 7 metres to safely pass through the channel. If it wants to enter in the morning, for how long will the channel be deep enough? So let's start first of all with the sketch. When I look at the graph, this is fairly straightforward. I've got amplitude, I'm going to have a change in my period, and I'm going to have a vertical translation. So let's work out everything that we need to know. And just to help me, I'm going to copy down the equation so I can work from this. So d of t equals 2 sine pi over 6t plus 6. So I know that my range is going to be given by 6 is going to be my midpoint, and then from 6 I'm going to go up and down 2. So I'm going to basically go from 4 to 8. That's going to be my range with a center line at y equals 6. So clearly I'm not going to have any time when the depth equals 0. There will be no x-intercepts because my minimum value of y is going to be 4. Then let's look at the period. Period is 2 pi on n, and n is pi on 6, which is the same as 2 pi times 6 over pi. When I divide by a fraction, I change it to multiplication and I take the reciprocal of the fraction. So that's going to give me 12. That's pretty logical because we've got a 24-hour period, and it looks like we're going to have a complete cycle every 12 hours, so we'll get 2 complete cycles in one day. It's probably not, strictly speaking, accurate with times. It's an approximation. With tides, sorry, not with times. Tides don't exactly go up and down twice a day, but that's what we're using because that's what we're given. All right, what else do I... That's all I need, so let's sketch it now. There's t. Take a moment to be really careful that you don't put the wrong variable down here. It's not x, it's t. And then I'm going to have 2, 4, 6, 8. So there's my midline at 6, which I always just jot down. Then I'm going to divide this up. There's 24, cut it in half to get 12. And then every period I'm going to cut into 4 pieces. I don't necessarily need to mark those in. You can if it helps you. All right, so because it's a sine graph, I'm going to start here at my midpoint and then go up to a maximum, back to the midpoint, down to a minimum, back to the midpoint, and repeat. I haven't marked these in. 2, 4, 6, 8, and then I'm going to join those with as smooth a curve as I can, trying very hard to make the shape look sinusoidal, which means that the line is fairly straight and at about a 45-degree angle at the midpoint, and then also not too curvy, but it's at its curviest in this little area here. It looks almost like a parabola if I just look around each minimum and maximum point. All right, so that's A, sketch the graph of y equals d of t, and I've done it for the domain of 0 to 24, which gives me 2 complete cycles. Now I need to find the depth of the channel and the time of day at high tide. I can do that quite easily by using my graph. So this is the answer to A. B, I'm going to look at my graph. I'll just grab a pencil. High tide happens here. There's high tide and there's high tide. So that happens at, that's 3, and that is 15. Remembering that 15 is 3 o'clock in the afternoon. So high tide is at 3 a.m. and 3 p.m. And I need to also know the depth, and that's going to be 8. Sorry. That's what I've written. High tide is at 3 a.m. and 3 p.m. The depth is 8 meters. And I'm out of page, so I'm going to go to a fresh page. But I'm still going to keep referring to this graph. So what I'll do is I'll just push this down. All right. Question C, calculate the depth of the channel at 4 a.m. So basically, question C is asking for d of 4. So all I need to do is substitute in d of 4, t equals 4, which gives me 2 sine pi times 4 over 6 plus 6. I'm going to use my CAS calculator to do that. So I've just put that into my CAS calculator. Now, there are no instructions in this question about decimal places, and that's actually my fault. I should have put an instruction about decimal places, but because it's not there, I'm going to write down an exact answer. So I'm solving when d of 4, when t equals 4, what is the depth? And I'm going to write down root 3 plus 6. All right, but what I'm going to do at this stage is I'm going to adjust my last question. I definitely want that, let's say, to 2 decimal places. So I'm just going to, now I need to change this, hang on. There we go. So I'm going to change part D to say to 2 decimal places. Okay. All right. But I haven't finished answering question C anyway. It asks me to calculate the depth of the channel at 4 a.m. I've done that. Is the tide coming in or going out at this time? I'm going to refer to the graph to help me with that. Here's 3. This is 6. So 4 a.m. is going to be around about there. All right. So that's good. It looks accurate because the answer that I got, root 3 plus 6, came to a decimal a bit more than 7. So that looks about right. But I can clearly see that the gradient is negative here, which means that the depth is decreasing, which means the tide is going out. So I'll finish answering question C. The depth is root 3 plus 6 meters at 4 a.m. and the tide is going out. All right. Now, the most complicated question, but it's not really that complicated, is D. A ship needs a minimum depth of 7 meters to safely pass through the channel. If it wants to enter in the morning, for how long will the channel be deep enough? And I'm going to calculate my answer to 2 decimal places. So what am I really looking for here? I want to know when the depth is 7. So if I just take a ruler and draw in a dotted line approximately where the depth is 7, I can see that there are going to be, I'm so sorry. Right. I've drawn this line across here and I can see that the depth is going to be 7 meters. It looks like it's going to happen a bit after maybe 2 a.m., something around 2 a.m., and something around, well, it looks like 6 on this graph. I think it's going to be more like 5. I don't really know exactly, but I need to know, the question is asking me, how much time is there in this space there, right? Because if the ship needs to pass all the way through the channel, it needs to know if it's got enough time. It doesn't want to get stranded with the tide going out and then suddenly it's a ship sitting on the sand. All right, so let's do our calculations. I need to find out when is the depth equal to 7 meters? And it's going to happen, in fact, 4 times during our 24-hour period, 1, 2, and 3, 4. And then it does say in the morning, so I'm just going to find out the time in the morning when that happens. So I need to solve 7 equals 2 sine pi on 6t plus 6. And once again, I'm going to use my CAS to do that. So let's bring up CAS. Come back, CAS. There you are. I'm going to do a solve. Oops. Oh, I need to flick. There we go. And I'm solving 7. Well, let's copy this down actually. And I want 7 equals this. And I'm going to change I made a mistake before. It's not 2 pi on 6, it's 2 pi on 3. Okay, let's fix this. Let's fix our answer to the last one. 2 pi on 3. 2 pi on 3. We'll go back and fix that in a sec. In the meantime, this is going to be pi on 6 times x. And I'll put in a little times there just because I'm not sure if my CAS will cope with it, and I'm solving for x. Let's do it all at once. It didn't change this one. Yes, it did. Give me that as an exact value. Root 3 plus 6, that's what I got before, isn't it? Root 3 plus 6. Okay. It's obviously the same. That's fine. Let's not worry about this. So let's look at the solution that I've got for solving 7 equals 2 sine times x pi on 6, which is, see if I can move this a bit. There we go. So, and if I shift that, you can see that. That's what I've solved. I've put that equation, and this is what CAS is giving me. It's giving me, and remember, I'm not jotting down an x, I'm jotting down a t. T equals 12 times a constant, I'm just going to pop in a k there, plus 1. Or x equals 12 times another constant. And let's see what it's saying there. Plus 5. Now remember that when we're solving for trigonometric equations, that constant is it's an integer, so I can make it 0 or 1 or 2 or -1 or -2. So let's try k equals 0. That gives me t equals 1 and 5. When k equals 1, that gives me t equals 13. And here I'm going to get 12 plus 5, which is 17. And that really does fit. Let's hide my CAS now. That does fit with what I can see on the graph here. Oops. That 1 and 5 is going to be here. And then the 13 and the 17 is going to be about there. So that's going to work. So that means that I've got t equals 1 and 5 is in the morning. So the ship has 4 hours to pass through the channel. And now I see why I didn't need to write 2 decimal places. Oops. Once again, you can't see that. The ship has 4 hours to pass through the channel. All right. Now, I just want to mention a few things about this example. One is we are given, the first question is to sketch the graph. That's not always given to you, but when it is, you want to use that graph to help you answer questions. And if it isn't, it can be really useful to sketch the graph anyway. It's good practice to sketch the graph, but mostly it helps you to understand the question. For example, that high and low tide question, I'm not sure I could have done that if I couldn't clearly see that at this time the tide is going down, it's got a negative gradient. All right, so sketching is always important. And the other thing is, even though you are using your CAS, because you will be using your CAS for these, if the question doesn't say to decimal places, remember to give exact values always, okay? Just because you have your CAS doesn't mean you can use it and give approximate values. You can use it, but your CAS can give you exact values. All right, so that's the end of our video on applications of circular functions.